All right, welcome back. This is a continuation of my video on the last one of the design of TSINC01. And this one's going to be talking a little bit about some of the different CAD techniques I used along the way with it. Um, so this will be a little bit more on-shape centric. I'm sure that you can take some of the ideas of this and apply them to other CAD programs. But this robot was made entirely in on-shape. So um, some of the tricks are going to be specific to on-shape. Um, so starting off, one of the things you'll notice about this, right, is that this says final up here. Um, what's going on here is that I actually have versions of this. So you can go back and check out what my progress looked like basically at the end of each day, which is, I think, a pretty cool thing to be able to go through. I did it so I could go back and look at what my pace looked like going through this cadathon and kind of how fast I was working on stuff. Um, this also has a side effect of making it when I'm doing a video like this loaded in a lot faster. And I think you'll notice if you go and you view things based on the versions, you'll notice that these earlier versions load faster than like will load pretty fast. So that's a nice feature of that. One of the other things you'll notice on the top level is that I actually have a few different configurations on here. Configure are a great on-shape feature. What these let me do is they let me toggle notes and then an overall um, robot volume, which is taking a second to load in here. Um, and oh, I hit it. Oops. But looks basically like this, and um, I add those at the top level, basically so we can see, like, make sure everything fits inside frame perimeter. Um, I have a extended bumper zone here that's like the general bumper zone. It's not exact, but it's close enough. One of the If you dig into this, you can take a look at this configuration panel. These configurations were all configuring suppression of various things. So I can turn this off and the that'll just be suppressed. This is pretty nice. Sometime I might do a video on how to use configurations. Onshape has a pretty good series in the Learning Center for it, but there's some specific things for FRC that I think people might find useful. So one of the questions I've gotten a few questions about this robot. One of the questions I got initially was, so how long did it take you to constrain all of those belts? Um, and the answer was, and also how long did it take you to constrain all? And the answer to both of those things is not very long at all. Um, and the reason it didn't take me very long, we'll dig into that here. So what I'm doing is I'm opening up the part studio for our carriage manipulator, and you'll notice, so this is all the parts that are basically that are a part of that assembly. One of the things you'll notice here is that all of the belts are done in this part studio. So, and not only that, they're actually done in place. So a belt in this part studio is exactly where I would expect it to be on the real robot, in the full assembly. What that lets me do is that when I go into this assembly, um, this like these are all solely constrained. Let's go down here. So this is a group mate where I just inserted and then grouped all of these and then fixed one of them in place. So for those of you who that isn't English for, um, when you're in a part studio, um, when you're in an assembly, what you can do is you can insert all the parts of a part studio at once. Um, and then what you do is you do a group mate, which just tells them that those are all in the right place relative to each other. Um, and then you fix one of those, and then all of a sudden everything's in the right place. Um, so we did that, and then what I did is I did a linear pattern. So you can see this is the same linear pattern for all of these different parts. Um, and that linear pattern means that I didn't constrain anything here individually. It took me almost no effort to do this many belts. Um, One of the things that I would caution somebody, and the same thing for the offset ones. One of the things I would caution anybody who does this is just because this is easy to do in CAD does not mean that this is an easy thing to assemble in reality. I would pity the person who has to assemble this and make sure that all of these belts are lined up and all of that stuff. Like it would just be a pain. Like I'm sure like it's very possible to do it. But just with all of the different places these are like I would like I shudder thinking about it. Um so one of the other things I did to save effort on this is it's hard to tell, but basically these belts, the whatever this set of 1, 2, 3, 4 belts is the exact same set of belts as these ones. These 4 belts. They're just inverted. Um, so this let me save on part count. In terms of like it would just make it easier to order that many belts. Like you're just ordering a bunch of the same belt, and you know that once you figured out all those belt spacings, you know that those are the right spacings. So um, that is another nice feature of this. Um, One of the other tricky things that I did here was this. So we have these gear reversals, and this is actually the exact same as on this side, which is just I don't know. I completely lucked out. Like that wasn't entirely intentional. Like I kind of was expecting I'd have to do a second plate here. Um, but what happened here was belts have some flexibility in exactly the right spacing that you can do them. So there's your dead center to center spacing um, that we'll call -0. But on like intakes and stuff like this, that's moving at high speeds that you don't really care if it might skip a little bit, um, you can actually go pretty much anywhere above that up to like -60 um, or so, whatever that's 60 thou, um, or uh, 0.06 inches. So what that lets you do is you like and you have to be careful with that, right? So that works in this case, basically because this is just a high speed thing that I don't really care about. That I don't really care if something skips in here every once in a while. Um, and I'd really just rather have the speed on there and the flexibility to place these right, to place these at the right place. And that flexibility gives you like it's pretty nice and it's pretty freeing and it opens up a lot of stuff. Um, like get like I said, you have to be careful about that. You don't want to do that on anywhere that you have high tension stuff, stuff like an arm. You wouldn't want to do that on. That's just a really bad idea to do that on an arm. Yeah, because you'll get skipping on an arm, and an arm like your position is your life on an arm. And this one, it's going faster. It's not going, and I don't really care as long as when it's going, it's going. So one of the things you'll notice here that I just want to call out, and I want to be clear, this isn't a dig at the author of this fantastic feature script. Um, so this interference here is happening only because the diameter of this is wrong. Um, so on an 18 tooth pulley, 5 millimeter HT will give you a radius of like just under 1¼ inches. Um, this you can see this radius is quite a bit over that, almost a 16th over that. Um, So that's where that interference comes from. I don't worry about that because like I'm not worried about that here because I know what size this is and I know that it wouldn't interfere in reality. It would be close, but it wouldn't. Um, so that's something to be careful on. One of the other things I wanted to talk about this, and focusing a lot on this mechanism because it's kind of a microcosm of the rest of the robot. Um, one of the things I notice here is that all of these gearboxes are ultraplanetaries. I love the Rev ultraplanetaries now. Like, this is probably the third robot I've designed using them um, since we got unceremoniously kicked into the off season, and they're just really nice. Like, they're super light. Combine that with a Neo 550 that's also super light. Really, the only drawback there is that you have to have a Spark Max close by. Um, One of the things I did in this project that is something that I'm probably going to just add to 2220's common parts is I started doing a lot of this type of pulley where it's a derived part, um, and it's offset. It has some level of offset from it. Um, and we'll bounce over because I started doing this around the Pluton intake, and then that's this right here. And what you can see here is this has a derived part from the MKCAD pulley, and it has a bunch of other features around something to give it an offset, something to give it a chamfer, and then some holes. Um, and the only reason that these are two holes is because counterboard is an option here. I could turn that on and off. I can take this in offset up to like 0.25 or something, right? To hit exactly whatever offset I wanted. Um, I could change the width of the pulley. That's this interior width here. So I can make that 0.375 and be a bit bigger, right? Um, so this is a super nice little part here that I kind of stumbled across as being just like a pattern, and is very nice. And oh, and then the other thing I added here is I used Julia's fantastic 3D printed feature script to create an estimated weight for this, which was a good call. Let's pop over to the loop mechanism. That's some interesting stuff going on there too. So this Pluton mechanism is a really good example of like this is a place where I suspect that most other people that would design something similar to this would add a bunch of lightning, but I didn't. Um, I just didn't think that was necessary. Like I added some down here, honestly, mostly just because it was fun. Um, but you just don't need it. I didn't need it on this robot, and honestly, like if I was making this in reality, I'd probably cut out the lightning down here because it just isn't necessary. Um, this is a pretty good example of really taking advantage of these tube spacers to make an assembly that would be super easy to drop in and drop out. So like in context, basically you unplug these Spark Maxes and you undo these four bolts, and this entire assembly comes out and you can swap it, which is really nice. Quick maintenance, everything. And this uses that same group and linear pattern technique on here that we saw on the carriage mechanism with timing belts. I think I called this out in my other video. The only thing that, like, the biggest thing I would change about this is that I would make this so that it can go back a little bit further, which you can see that it does have the range for. Um, and then add a bar out front to protect this. Might also make it a little bit wider, but honestly, I don't think that that's 100% necessary here. I got asked how I did these decals. I'm sorry, I don't have a trick for doing good decals. Um, these are just like a total hack. So what they are is go down here. So it's a sketch extrude on text. And then what I did is I made a composite part um, out of each of those decals. So, like, I'm sorry I don't have a trick for doing nice decals. Those are like the easiest possible non decals that you can get. Um, you can see that I've kind of leaned into a little bit more of this derived parts workflow. Um, a lot of these actually don't really have any references. If you went back to these main sketches, like you would see that they don't actually. That one it only uses this. Like it doesn't use this lower bar. The lower bar there is just for context. Um, so that's pretty nice. Uh, so I'm going to go back to this carriage manipulator, talk about a little bit, one more thing about this. So I think somebody might ask me, why did you lighten this, but not lighten other things? And the answer is this is something that moves. And not only that, but this assembly is really probably too heavy. Um, this whole thing is so. Let's go to the full one. So this full one is like I want to say it's like 24 pounds. Yeah, 23.703. So like 24 after you add change. So this manipulator is heavy. Like this is like 30 pounds of motion, which after you cut out the 26 pounds that we add to the base, like that is a third of the robot weight is this manipulator, which is bad. Like it's that's really bad. Um, so I don't know. I would have liked to make this lighter. I don't have any great ways of doing that, unfortunately. Like, yeah, I could lighten these guys out, but they're for the disclaimer. Um, I ended up just saying I'm gonna do everything that I can, and then I'll add as much ballast as possible to it, which isn't a great solution, but is what I did. I also think that these timing belts might be a little bit heavy, but I'm not 100% sure. These are designed, these Spark Maxes would literally be zip tied to these bars in a real robot. I didn't model zip ties because I don't like modeling zip ties. There's kind of a pattern, like if you talk about things that I didn't model on this robot, it's basically stuff that I wouldn't model on a real robot, um, or that I was just a little bit too lazy to do, like the rigging. Speaking of the rigging, let's bounce over to the elevator. You can see that um, I did actually start modeling the rigging. It's a little bit off from reality here, um, but there is like I did think about how this would get modeled. Unfortunately, like this exact what kept me from keeping that in the top model is pretty much that this make this actually work, you need a lot more planes. Like this is relatively simple rigging to do in reality, but hard rigging to model in CAD. Um, I'm reasonably confident. I don't know. I'm of two minds of whether it would actually work super well or not. Um, which isn't a great place to be in, and isn't what I would accept, like putting onto a real robot. Which is this way would be like another 2 pounds. So, like, yeah, you end up with like 30 pounds of motion on this elevator, which is not great. But does actually mean that like the part of the robot that's lifting this um, ends up a lot lighter than would have initially thought, which is a little bit weird. this is kind of what that full elevator ended up looking like in CAD. Um, so this style of elevator gearbox is something I borrowed from 1678. There's a lot of power on here because at one point I thought that I might add a buddy climb. I ended up not. If I did that, I probably would have had to put a little bit more time into this. Which is one of the features you'll notice here is that I didn't extend this all the way out to here. Really, you probably do want to do that. I didn't in this case, basically because if 2220 was building this, we probably wouldn't do that. Just because we have like getting those angles right is a pain for us with our machines, and we're trying to get better at that. But I kept it this way for roughly that reason. What else do we want to talk about here? If you want like the most unrealistic part of this thing, it's probably these guys, which are basically these little. Are these even an actual extrusion? Remember? Yeah, so these aren't even an actual extrusion size, which is hilarious to me. Oops. So those were intended to be 1x1s, 1x1 L channel. In reality, we probably would have just cut those off at 1 inch segments and drilled some holes in there and not like done any rounded corners or anything. Like that was just a little silly catathon thing to make it look better. What else do we got here? Do I have? So here's a fun little bit. So this is the energy chain, which looks probably a little bit different than a lot of the other models because this is imported from McMaster-Carr. And the way that I did this is, so first I had to figure out the link spacing here. So you can kind of see that, and then space this out. And what it is it's a linear pattern, and then like there's a bunch of just transforming things in here, which is, I don't know, it's really weird. Is the truth. I don't do a ton of stuff like this, but it ends up with a pretty cool result. Somebody who has listened to me on Discord or in my previous videos might be like, so why did you just clone this part a bunch in this part? So you keep on telling me not to do that. The only reason I was comfortable doing with this is because the end result of this is a composite part. I would not be comfortable doing this if the end result was not a composite part. And really the difference there is that, oh, hey, this ended up a little bit off. That's funny. And really the difference there is that when this gets into your actual assembly, the composite part is all that shows up. It's not all these parts. These extra parts don't show up in the BOM. They're just, they exist here to help. This has a few different drives in there. So it has the import of the initial chain, and then it has some drives for the end pieces, which is how those got in there, and then some transforms. And the way that these transforms work is they're transformed by mate connector, which is a really powerful way to do transform. It's basically like using a fastened mate in your assembly. Man. And this sketch was basically just, so it's not actually there. Actually, it was there for a reason. So this was there to get this angle right, but also to visualize what those rotations looked like around that bend. So that was a fun bit. That was the first time I've ever done anything with energy chain in a CAD model before. 2220 hasn't historically built any elevators. And if we had, I doubt we would have done the energy chain model because, like, we just aren't there yet. What do we got here? So we got those. We talked about just about everything. Is there any cool tricks that I did on this drivetrain model? So tricks on this drivetrain model. Actually, this is probably really the only trick that happened on here is this little bit here. So what this is a derived part that's just a lathed down version of this sprocket. That what that did was gave me clearance to run rivets along the top of this at each of the end caps. So you can kind of see if you dig into this drivetrain, right? If I didn't do this, what would have happened is, well, it might not have happened actually. These rivets would have run the risk of hitting there, not on that side, but this side, right? And you don't want that. You want to be able to use all your rivets as much as possible while avoiding hitting the chain when you're doing a chain in two drive like this. One of the things to notice here is that the final model of this has a ton of rivets in it, but this one doesn't. This is the drivetrain model, and it doesn't have a bunch of rivets in it. The reason I did that is because oftentimes I find myself making changes to this, and it's annoying to have like 1,000 rivets in there, or whatever the 400 or something that I had in here. So I have a separate model that has all the rivets in it, independent from the rest of it. So you have the whatever, 100 rivets in. Yeah, the 334 rivets that are on this drivetrain are not in this primary assembly because this is where I do most of the work, and I don't want to deal with that. A lot of the individual fasteners and stuff are, but the other stuff is not. What else do we have here? This isn't lightened. Again, not lightened because I actually want more weight down here. So we just didn't lighten that, and that means that those would be faster to machine and add those extra ounces on here, which is nice. I was a little bit lazy about adding bumper mounting on here. What I would have liked to done if I had taken a little bit more time on the bumper mounting, what I probably would have done. We'll bounce back to the top level of this. What I probably would have done here is basically added a piece of L here that rests on this, and then added a 38 Spectrum has this really cool method that I guess they borrowed from 118 or somebody else. That's pretty much like they have a plate here that has a slot in it that this drops into. That's probably what I would have done. That's probably what I would have liked to do for the bumpers here missing. So that's pretty much it for all the modeling tips and tricks. Like always, feel free to reach out if you have any questions about this robot. I'll be putting up these videos, and then also doing a follow-up probably with the talking a little bit about the robot design sheet that I used for this, which is derived from spectrums. Thanks for watching, and have a good one.